Hello everyone and welcome back where we've been tackling FRQs in preparation for our AP exam, and today we're tackling one from 2011. I've been trying to avoid ones that I've done in class. This is one I've seen a bit, so I think I've done it in class. A, I'm not quite sure, but B, we're starting to run out. At this rate, we're going to end up doing all the FRQs based on arrays and array list, and hopefully a lot of the ones dealing with classes and objects. But let's take a look at this one from 2011, number one. Digital sounds can be represented as an array of integer values. For this question, you will write two unrelated methods of the sound class. So here we see public class sound. There is a instance variable, an integer array, and samples is our name. Then we see this method, LimitAmplitude, which takes in a limit and it returns an integer. It's going to end up, this is what we're going to do in part A, but it changes those values in the sound that have an amplitude greater than limit. Okay, values greater than limit are changed to limit, values less than negative limit are changed to negative limit. And a bit of a precondition here, limit is going to be greater than or equal to 0. Okay, to be done in part B, we're going to trim silence from beginning. So it removes all the silence from the beginning. Silence is represented by a value of 0. Samples contains at least one non-zero value is our precondition, meaning that this has stuff in it, at least one. That's going to be super important later on. And our postcondition, the length of samples, again, our instance variable, reflects the removal of starting silence. Okay, let's go ahead and create this sound class in IntelliJ, and we're going to probably have to end up making a constructor to kind of test this with. So I'm in IntelliJ. I'm going to go to File, New Project. Do a next, and this one is from 2011, so I'm going to stick it in my 2011 folder, and it is number 1. I'm going to expand my project folder, right click on the SRC, make a new Java class, and this one is called Sound. I'm just going to paste in the stuff that they gave us, and we're going to end up formatting it. So here is our instance variable. All right, let's clean this up a little bit more. This is actually looking pretty good. I do like having these on the next line, I think. So this is part A, which we're about to tackle. Do some new lines to kind of scooch that up. There we go. This looks pretty clean. Now, one of the things I said is that we're going to have probably a constructor to do testing. Now, they don't give us a constructor. All they ever say is there may be instance variables, constructors, and methods that are not shown. For us to test this, let's plug in a constructor, and the easiest thing to do is Alt-Insert based on this instance variable. And we could do a no-args constructor and then add integers. That doesn't seem great. The easiest thing to do is maybe use an initializer list in our driver to kind of create an integer array, and then we'll pass it in to actually create a sound object. So this is the only constructor I really need, but I need it to test. And eventually, just big brain, we're going to need a toString. And that toString is just really needs to be the contents of our array. So I'm going to use something a little sneaky here. Coming out of the arrays class, which already exists inside of Java, is a toString method. And so all we're actually going to spit back out with this toString is the most important information, which is the contents of our integer array. And so arrays.toString will give me just that. We're going to do a arrays.toString on samples. This is coming out of arrays. It's a static method. Everything in the arrays class is static. The difference being is we're not using object orientation. I didn't actually create this object. I'm just referring to a method that is in the arrays class. So no implicit parameter, only an explicit parameter. That's going to produce a toString, and that toString, for what it's worth, is something along the lines, it looks a little bit like this. In terms of, I fat fingered that, I promise. In terms of what it's going to return, this is what it's going to look like. So it's just going to give us back the contents of our array in this format. Okay, so let's get started on part A. The volume of a sound depends on the amplitude of each value in the sound. The amplitude of a value is its absolute value. For example, the amplitude of negative 2300 is 2300, and the amplitude of 4000 is 4000. So absolute value. That's kind of a big hint, right? Write the method LimitAmplitude, which will change any value that has an amplitude greater than the given limit. Values that are greater than limit are replaced with limit, and values that are less than negative limit are replaced with negative limit. The method returns a total number of values that were changed in the array. For example, assume that the array samples has been initialized with the following values. Ooh, I hope we can kind of copy and paste this into our driver. That'd be pretty awesome. But suppose that this is our sound wave, and keep in mind, we're talking something like this. A sine wave, and what these kind of represent are the heights of those things from their distance from zero, which can be positive or it can be negative. So whenever we go through and limit these things, and we're assuming in this example we want a limit of 2000, right? We're going to go through and ask, is this greater than a positive 2000, or is it less than a negative 2000? It is neither, so it's not going to get touched, and we see that here in our output. This one we're going to ask, is it greater than positive 2000? In this case, it is, and so we're going to end up replacing it with positive 2000, and we see that here. All right, 17 is fine. This negative 2300 is less than a negative 2000, so it will get replaced with negative 2000, and that's all we're doing. We're going to go through and change samples. Right, samples is the instance variable that's inside of this sound object. Okay, now in this example they use 2000, but in practice it's going to be this parameter. So let's get started. What I want to do is loop through samples, and with each iteration I'm going to ask, is the current value greater than limit? Is the current value less than negative limit? Okay, so let's start looping. Because there is the possibility that I change the current element, right? When I'm here, this is one that ends up getting changed. Because of that, I'm going to need to save values back into the array. What that tells me is I'm ultimately going to need an index. And I say all that to say that a for each loop is probably not a good idea. We instead want to use a for loop. And I'm going to use IntelliJ's shortcut syntax here, for I, which will auto-generate that stuff. We're going to start at index 0. That looks good. As long as I is less than samples.length. With each iteration, I'm going to ask, is the current element greater than limit? Is samples at I greater than limit? If so, I want to update it. I have found an element that is greater than my positive limit. So I'm going to change it to limit. We're going to save limit back into the current element in our integer array. Okay? I'm going to use an else if here, right? So if I hit this else if, what it means is the current value is not greater than limit. That means the current value is going to be less than or equal to limit. But what I'm most curious in is the current element less than, all right, we're checking the other side, negative limit. Okay. In my experience, a lot of students don't know that you can just throw a negative sign in front of a variable and treat it as such. And that's perfectly fine. If you did not know this, one thing you can do, and I have seen before, is multiplied by a -1, right? But that is ultimately unnecessary, and so the cleanest looking thing to me is let's just treat this thing like a negative. If the current element is less than negative limit, I want to replace it. And what I want to replace it with is negative limit. Okay? Now, something of note is we ultimately need to return an integer. So what that means is as I'm looping through and finding these things, I need to keep count of them. I need to track them. So I'm going to create some type of counter variable before we start looping. And every time I do this, I need to update my count, right? So here I found one that was greater than my limit. I updated it. Let's count it. Here I found one that is less than my negative limit. We need to track that one as well. Okay. And we're going to do that for basically every element and samples. And so once our loop is finished, I should have an accurate count. We just return that count. I'm going to test this bad boy. Okay, here's our logic. We have a counter variable. We're going to loop through samples. With each iteration, I'm asking, is the current element greater than my limit? If so, I set it to the limit and I count it. Otherwise, I'm going to check it to see if it is less than my negative limit. If so, I'm going to set it to my negative limit and count it. We do that for every element. I can return an accurate count afterwards. All right, I'm going to right click on the SRC. Let's make a new Java class, which I am calling driver. We're going to plug in a main method with PSVM. And hopefully I can do some copy and paste magic here to grab those values, because we're going to create an integer array. I'm going to call it something other than samples. So this is coming from the example, and we're going to use a initializer list in order to get that going. Sweet. So all I got to do is come in here and throw in commas. And a semicolon there. So this is the first example they gave us, right? And we know we want it to look like this when it goes through our method. So let's try it out. First of all, I'm going to make sure, let's create a sound object. And we're going to pass in the array that we just made to set the initial state. And what I want to do, let's not throw an S on that. What I want to do is take a look to make sure that our instance variable is getting initialized with the values that we have specified here. And there it is. That looks pretty good. Okay. Now I want to actually test what we just wrote for part A. So I'm going to take that sound and we're going to limit the amplitude using their example 2000. In order to visualize that change, we need to actually print it off again, right? So we're going to see it in its initial state. We're going to then put it through the limit amplitude, and then we'll see the post state after the fact. And any value that was outside of our limit, you see has been corrected. Also super important is this is actually returning a value, but I'm not actually displaying it, right? We are modifying our object. That part of it's working, but it also needs to return that count, right? The count variable that we made, which should be the number of things that got changed. So let's try that. I'm going to take that exact same method call, put it inside of an SOP. We see we should have 1, 2, 3, 4, 5. And there we go. 5 things ultimately get changed. That's part A. Part B. Recorded sound often begins with silence. Silence is a sound. In a sound is represented by a value of 0. Right? Nothing here. Write the method trim silence from beginning that removes the silence from beginning of a sound. To remove starting silence, a new array of values is created that contains the same values as the original samples array in the same order but without the leading zeros. The instance variable samples is updated to refer to the new array. For example, suppose the instance variable samples refers to the following array. So here is sample starting out, and you see that we got some silence at the beginning, but of note, maybe a little bit of trickeration here, they've thrown some zeros in throughout. After trim silence from the beginning has been called, the instance variable samples will refer to the following array. And so these 4 values, they end up getting removed. Okay? Now, it's going to be super, super important, right here, our precondition. Whenever we call this method, we are guaranteed to have at least one non-zero value. Okay? So that what that is saying to us is they're not going to throw in an empty sound. They're not going to give us an array with no zeros in it. And that's super important with how we're going to end up writing this method. Let's get started. So I'm over in getting ready for part B. What we want to effectively do is transfer these elements to a new array like this. In order for me to perform that transfer, the destination array has to exist. I have to have a place to transfer these things into. In order for me to create an array, I have to have a length. Right? I have to create this array in advance before I can transfer these things into it. So what that means is the very first thing we need to do is figure out how long should this array be. And the way that we're going to do that is if you look, right, the original array has a length of 16, right, because 0 is going to kind of offset that number. There's 16 total elements here. My final one has 12. It's a difference of 4. That is these 4 zeros that occur at the beginning. So we need to count these zeros, and then we just simply subtract that number from our total length, and that'll tell us how long the new array should be. So the first thing we need to do is count those zeros. I'm going to create a new count, and it is number of zeros. Maybe a good variable name is zeros. Let's call that something else. ES? S? ES? Help me out, chat. We're then going to loop, but not through the whole thing. I just need to loop counting until I encounter something that's not a 0. What am I saying? We're going to loop through this thing, and we're going to keep going until we run into something that's not a 0. And then that's how I know when to stop. So here, a while loop makes sense because I'm not going through the whole thing, but I do need to loop over and over and over again. We'll say while the current element is not a 0. Okay, the current element, well, this is coming from samples. And in order for me to reference a value, I'm going to need an index. Okay, we could actually use this value, right? Because initially it's starting at 0. Now, one thought is, well, I don't want to mix up these variables. I don't want to use the counter variable that's tracking my number of zeros as an index. In this particular problem, they're ultimately going to be kind of the same thing, right? Because what we're looking at is number of zeros at the beginning, right? I'll say while samples at zeros is equal to a 0. While the current element is a 0, we'll increment zeros. Okay, let's plug in these values so I can actually give you some examples to this. I'm going to throw this over here as a comment so that we can kind of test this. Ooh. Is that the numbers? That did not copy and paste the same way. I'm going to end up having to paste these into my driver anyway, so let's separate them out. So 39. Yep. Is this -7 or -71? 16, 32, 37, 29, 0, 0. So ultimately, this is going to, I'm just going to end up copying and paste this from here into an array in our driver to test it. So I went ahead and just kind of formatted it, plugged it in. That's perfectly fine. So zeros is starting out at 0. Why don't we kind of track it here? Okay. We're going to ask, is samples at zeros equal to a 0? Well, zeros is currently 0, so we're looking at samples at zeros. That's this element. We're going to ask, is it a 0? Yeah, okay. Let's increment zeros. Zeros is now 1. Let's ask, is samples at zeros, which is now a 1, is this equal to 0? It is. So let's increment zeros. Zeros is now 2. Is samples at zeros equal to 0? It is. We'll increment zeros. Is samples at zeros equal to 0? It is. So we'll increment zeros. Is samples at zeros equal to a 0? It is not. So we'll stop looping, right? We'll say this is false. We do not enter the body. That's the end of the loop. I would now be here. And you see that the current value of zeros is 4. I've counted 4 of them in total. This was pretty clean. I mean, I've seen lots of student solutions to this where they end up trying to use like a for loop or something. And this is ultimately the cleanest approach that you can kind of do here. So zeros has a value of 4. I've counted my total number of zeros that occur back to back at the beginning. I want to now create the array that I'm going to end up transferring these values into. Okay, so let's do that. We'll create an integer array. I'm going to call it temp. And it is a new integer array. The length, as we talked about, this was originally 16. I need to get rid of these 4 zeros. This has a value of 4. So the new length is going to be what samples currently is, minus our total number of zeros that occur at the beginning. In this example, that'll give us a length of 12. So now I have created an array that I want to transfer these things into. Sorry, I shouldn't highlight the whole thing. I want to transfer these elements into it. Okay, here's where things get tricky. Sample still has a length of 16, but I want to transfer into temp, which has a length of 12. Right, so there's going to be some offset. Now, again, I've seen a lot of different approaches to this coming from students, but the big brain thing is to kind of recognize that offset, the amount that we're offset, right? This value needs to go into index 0. Ultimately, what I want, let's maybe put it underneath. That's not smart. Ultimately, what I want is this array. Right, so we're taking this element, which is at index 4. So I want to take from index 4 and go to index 0. This one needs to go from index 5 and go to index 1. This one needs to go from index 6 to index 2. The amount that we're offsetting by is 4, the total number of zeros. Okay, we're going to loop. In this case, a for loop makes sense. We're looping through this section. Right? A couple of different ways to do this. I want to basically pick up where we just left off, which should be not at index 0, but index 4. Again, this has a value of 4. So let's start I at zeros. We're going to go through the remaining part of samples. So with each iteration, I want to transfer into temp. And that element is coming from samples. Well, this part is actually easy. Right? It's just whatever the value of I is. So we're going from index I. I think this is just red because of this. So we're going from index I, which is going to be there. And it needs to go here. I currently has a value of 4. I need it to eventually go to 0. We're going to offset by an amount, and as I talked about, that amount is equal to zeros. Okay, so whenever I is here at index 4, we subtract zeros, which has a value of 4. That gives us 0, and so we're going to insert into temp at 0, pulling from samples at I would then increment, putting it here. that has a value of 5. I want to take from 5 minus 4. I want to insert into temp at 1. Coming from samples at I, it would go there. Now, all this is good. So this is transferring elements. This will go through the rest of samples, transferring elements into temp. But this is not changing samples, right? I'll show you. Right? We do all this work, but all I'm really doing is populating temp. Right? We can demonstrate this in our driver. Why don't we comment out this example? We're working with a different example. And do I still have it pasted? Sweet. So, we need those zeros. So let's grab this. So I'm going to create the second example using an initializer list. We're going to pass that into our sound, and you see we have these leading zeros here. We're going to see it in its before state. Our limit amplitude doesn't matter, so why don't I comment that out? What I want to do is take the sound, and I want to trim the silence from the beginning, and then we'll see the sound after the fact. Right? So this should be its initial state with these zeros. We call trim silence from the beginning, which should get rid of these zeros, and then we see the after effect. Notice there's no change. That's kind of my point on what we're getting at here is I do all of this work, but all I'm really doing is modifying temp. We ultimately need to modify samples. And it's very simple. We're going to set those two things equal to each other. And I want to talk about this for a moment. But let's see how that works. Right, exact same code. I just ran it again. And notice that samples looks good. There's no zeros at the beginning. I'm pretty happy with this. Now, this little line of code, this is messing with pointers ultimately. And some people are kind of recognizing what's going to happen here is that there's actually going to be two variables. You have temp that's going to be pointing to an integer array, right? The one that we populated there. And then right here, we're going to tell samples, which is also a variable. It's an instance variable. We're going to tell that instance variable to point to the same thing that temp is. What I have is two variables referencing the exact same object. In theory, there's the possibility for side effects. Changing temp also changes samples and vice versa. That could potentially be a problem, except temp, the scope of it, is this method. Temp only exists in the scope of this method, which means temp stops existing here. The moment this method ends, temp goes away. Right? I got those two pointing at the same array, but whenever the method ends, temp goes away, and all we're left with is samples. And this is the biggest difference between a local variable like temp and an instance variable like samples. The lifespan of temp is limited to this method, right? It is declared here. It stops existing here. The lifespan of samples, however, the instance variable, is the moment you create the object, it will persist, it'll exist as long as the object exists. Okay, so temp goes away, sample sticks around, and it is ultimately the only one pointing to this array. Guys, that's it. That's A and B. We knocked it out of the park. Let's chill.